Basic lab setup here. Pressure regulator and valve. Before you start your lab, make sure the pressure regulator is all the way open. Why? Because, well, counterclockwise reduces the pressure, clockwise increases the pressure, and that being the pressure coming out of it. So with the valve closed, back it all the way out, then slowly open the valve, observing the pressure, making sure that it doesn't just jump up and give you a very high pressure. Why? Because most of our components have acceptable pressure limits, and we do not want to overpressurize them, right? If I was plugged directly into this here pressure transmitter, well, it's good up to 25 psi. Well, I would not want to exceed the pressure on that, so be very careful. Now, granted, we're going to be setting up like this. We're going to have our current calibrator giving a current signal to my I to P transducer. This I to P transducer receives a current signal and gives me a pressure output, right? And outside of this, so we have an in and an out. Be aware that there's an in and an out. So you connect your line coming out of the regulator to your pressure transducer. The output of the transducer goes to this fancy gauge here. And then out of that fancy gauge, we go to our pressure transmitter. So our pressure transmitter requires a 24 volt DC supply. We've already supplied 24 volts DC to it. You would connect it like such. And then you want to read the signal off of it. So you'll be connecting your leads like so. You need a reference. And then this is your 0 to 5 volt DC output. You can see there's already an output. This is set to operate. So this is 4 to 20 milliamps will give us 3 to 15 PSI output from the transducer. We'll see that change here anytime I adjust the signal. You see as I move up to my 20 milliamp signal. Whoa, there you go. I move up to my 20 milliamp signal. We're very close to it. I get my 15 PSI output. Now this pressure transmitter is calibrated to give me a 1 to 5 volt DC output on a 3 to 15 PSI signal. We went through some of the math on the board there, and there's some additional videos that I'll be posting, and I have posted about the signals math. Make sure that your voltmeter is set to DC volts. See this here? There's a select button. When you turn it on, it'll be automatically AC. You will not see AC. Squiggly line, AC. The straight lines and the dotted line is DC. Make sure you're set to DC if you want to see something come up on your meter. So here we go. I'm going to go back to 4. And as I bring it down to 4 milliamps output, which is going to bring my pressure down to 3 psi, we're going to see a little bit over 1 volt DC. So our span here is 1 to 5. That's 4 volts DC. My offset is 1. Here, our lower range value is 3. Our upper range value is 15. And our range, our entire process variable range, is 12. Here, we have our signal side. We have 4 to 20 milliamps. That means our offset is 4. And our span is 16. Our span is 16. So one more time, I've adjusted the 0 to my offset value, right? The offset value was 4. The definition of offset was the value to which I set my 0. So when I brought it down here to 4, which I'm quite rapidly doing, I then adjusted my 0, instrument 0, right? And when I brought it up to 20, I adjusted my span. And I went back and forth until I had a degree of accuracy. I calibrated my instruments. So I'm going to keep this video short and sweet. Hope you all understand what's going on. And get ready for labs next week.